Thanks, Susie. Hi. So I'm just going to do a quick show of hands before I start my story. How many of you would say you were confident that you knew what nanotechnology was? Okay. 40% of the room. How many of you would be confident that you could define it? 5.5% of the room. So I'd like to start today with a little story based on the fact that you know very little about nanotech, and we can go into as much detail as you like, about how nanotechnology is killing the whales and other fictional stories. So it all starts in the beginning. Once upon a time, in the 16th century, medieval artisans discovered that adding gold chloride to glass produced the color red. They also discovered that adding silver nitrate to glass while heating it up added the color yellow. And so the first incidence really of nanotechnology being commercially used was in the building of cathedrals and churches in the 15th and 16th century, and that is the origin of stained glass coloring. And so people are like, nanotech, it's all so new and shiny. No, it's really old. We've been doing it for a long time. We understand the science a little bit more, but the beauty of it has been around for a really long time. Not just used in stained glass, it was used in pottery, it was used to make pottery iridescent. It's just been used probably since the 14th century, originally from first traces. What they didn't realize at the time, and what we now realize because we have cool microscopes, was gold, if you make it into nano-sized particles, and I'll define for you what nano means in a second, if you change that size even by a little bit, it appears to be a different color. So when you say the word gold, you think gold, right? You look at a ring and it looks gold because you're looking at the macro scale. You're looking at a big piece of it. But if you make tiny pieces of it, you can actually go through a whole color spectrum of red to blues. And so this is what the stained glass experts were actually doing at the time, not realizing, but by changing their temperature and the amount that they were agitating the glass, they were actually creating these different sizes of nanoparticles. The same thing happens for silver. And you can create yellows and blues and reds by not this time changing the size, but by changing the shape of the nanoparticle. So is it round? Is it a pyramid? And what we have is this theory called surface plasmon resonance, which is how the electrons from light bounce off the surface of something that is very, very small and has a massive surface area to make your eye resolve a different color. So nanotechnology started, well, the use of nanotechnology commercially started then. In 1910, Goodrich began to change the color of tires. Tires used to be white. Most tires were either white with a yellow tint, because rubber, which they were made from, comes from a rubber, taking it from the tree, and that is a yellow-white color. And so tires used to be white. And then in 1910, somebody said, let's add this thing called carbon black to tires. And that is why tires now look black. We still add carbon black to tires today. And the nanoparticles of carbon actually react with the rubber. They make it appear black, but they also make it abrasive resistant, so you can rub it against surfaces, make it technically stronger, with tensile strength stronger, and make it last a lot longer. It's also more resistant to UV. So before 1910, tires were white. And now they're black because of nanoparticles called nanoblack. Again, they didn't realize this is what was happening. They were just like, hey, if you add a bit of this into a bit of that, things last longer. 1959, a famous physicist called Richard Feynman gave a talk called There's Plenty of Room at the Bottom. And I live at the bottom, if we're considering the bottom to be the place where our smallest atoms and molecules actually exist. The word nanotechnology didn't exist at that point, but he gave this amazing lecture that was all about this room at the bottom, the fact that we have atoms and we might be able to see them and maybe one day we'll manipulate them. And he actually gave the first real conversation about these things called little robots, little surgical robots, in which he dreamed of a future where you could have doctors in little robots that you would swallow and they would fix you. So this was sort of the time that electron microscopes were being invented. And so the technology of us actually being able to see nanoparticles was around this sort of time, a very exciting time in science. And the word nanotechnology did not actually exist until a paper was written in 1974. So that's why it's considered a new technology, because actually we didn't have a word for it until very recently, even though we were doing a lot of it previously. So scientists argued. We love to argue, actually. We really enjoy it. So we argued and argued and argued, trying to define what this word nanotechnology meant. And we're still sort of arguing, but there's a general consensus that it means an object of 100 nanometers in one direction or less. And that usually doesn't mean anything to anybody. So translated into the real world, if you have hair on your head, and you are a human, which I hope you all are, don't know about the hair on your head thing, but hopefully you're all human, then the width of that hair is around 100,000 nanometers in its width. It's going to depend on your race, it's going to depend on your age, it's going to depend on lots of things. If you're Asian, your hair tends to be slightly more than 100,000. If you're Caucasian, it tends to be about 80,000, give or take. And we can always do this experiment. If you take one of your hairs from your head and pluck it, and if you don't have any hair, I'm sure the person next to you will gladly donate a hair follicle for science. Just pluck it off the person in front of you. And you take a look at it, you should be able to see. Can you see the hair with your eyes? Okay, so you can resolve with your eyes 100,000 nanometers. So I do things in the nanotechnology world that are 1,000 times smaller than that. And I can't see that. And that's why my job is awesome, because I can say a whole bunch of stuff and you have to believe me. My biggest gripe about the word nano is, please only use it in its defined form. You now know that it's 1,000 times smaller than the width of your hair. Your iPod Nano is not. Ever. No compromises. That's all I have to say. And those of you who tell me, just wait a nanosecond again. I don't compromise on certain scientific things. That is one of them. So this increased surface area of making things really, really, really tiny makes things behave differently. So you know that gold is different. Gold is a different color when you make it smaller. Things can be more reactive when you make them smaller. Now this can have a whole bunch of surface area and very little volume. What's cool, and what I didn't understand, and I thought I was doing things wrong for a long time, is I was making little balls of nanoglass. And so I know, living in the human world where I pick up glass and I shatter it by throwing things, it breaks, right? You know that when you drop a piece of glass, it will shatter. I was just dropping these little nano balls of glass, and I was waiting for this massive shatter, and I had this, SEM, scanning electron microscope, and I was going to video this, and I dropped it, and it bounced like a bouncy ball. I was like, darn it, I need to drop it harder. Drop it harder. Bounced. I assumed I was doing something wrong. I was like, well, maybe I can drop it from a different angle. Bounce. Maybe I'll make it smaller. Bounced more. I'm like, this is glass. It's supposed to shatter. We know this because in our big world, you drop glass and it shatters. Nanoglass actually bounces like a bouncy ball, and I did this experiment for about a year before I realized I was actually right. So I never believe myself. When things don't go the way I think, I always assume that I'm doing the experiment wrong. And the reason for that is things break because of defects. If anybody's tiled their bathroom, I have recently, you know that if you want to cut your tile, you don't just saw it, you score it. And you score it with a diamond scribe or a tile cutter. And the reason why you do that is because you want to put defects in the atoms. You want to remove some of those atoms, you want to make a defect, and then you just click, and it breaks. Because things break, the idea of fracture mechanics, I'm a fracture mechanics engineer, things break because they have defects in them. So when you want to break a tile, you score it to put defects in, and then it breaks. Glass inherently at the big scale has defects in it, and so it shatters. Nanoglass is so small and so perfect, there are no defects. So if you don't have any defects, then where is it going to break from? Well, it doesn't, so it bounces. And that is why the nanoscale is fascinating, because I live in this world where I can't predict the future. And actually everything I think is happening is totally different. Things are conductive, things are different colors, things bounce, things break, it's like a magical wonderland world. And it all happens because of this massive surface area to volume. Chapter 2. For those of you who don't know, my name is Nano Girl. I don't think anybody even knows my real name anymore, so we'll just go with that. So Nano Girl was a young girl obsessed with gaining superpowers. She still is. And she spent her childhood trying to fly and read minds. Continually jumping off things and doing this with it. Why does this work, right? When you put your fingers on your temples, it's like the mind-reading sign. As she grew older, she became obsessed with science fiction. You've seen that I've named my dog after a Star Trek. And I read this book that changed my life. Has anybody read this book called Prey? Okay, yes. Right? You know it's all about nanobots taking over people's brains and then taking over the world. I love this book. And I wanted to make this real. The idea of nanobots taking over the world was a big thing, and so I decided to Netscape, this is how long ago it was, before the era of Google. This man, this is Professor Adrian Mann, who's one of the few people in the world who happened to be living in America where I wasn't, who decided to move to Rutgers, New Jersey and set up this nano lab. And so I called him up, and I was living in England, and he was in America, and it was one of those old rotary dials, right? So even the process of ringing him took 5 minutes. And I just finished reading Prey, and he picked up the phone and I was like, oh, no, are you the man who takes over people's brains with nanobots? I'd really like to join your team. Click. Need a new plan. Waited 2 weeks. Dialed the number again. Put on a funny accent, pretending it wasn't me that called 2 weeks ago. Hello, I am very interested in nanotechnology and believe you're the best person in the world. I was wondering if you had a PhD that I could come and sit in with. Oh, yes. Blah, blah, blah. End of story is I moved to America and do a PhD under this, my PhD advisor, Adrian Mann. Did all that, eventually decided to come to New Zealand and set up my own little nano lab, which is actually in this building. Underneath you right now in the basement is my nano lab. And I decided, so don't jump too much because the equipment's very, very sensitive to vibration. I decided to become a nanoscientist to use nanotech for good, not evil. And my goal was still to secretly seek out superpower nanotechnology research, and most of what I do is break stuff. I also wanted to protect the world from nano-nonsense, and there's lots of that out there. And so Nano Girl actually strives to protect the world from nano-nonsense, because you'll read all sorts of stuff about how nanotechnology is going to save us or eat us or control us. And actually, how do you know what is true? Chapter 3, Brain-Controlling Nanobots. I was really surprised how often I'm asked, are nanobots going to eat my brain? Are nanobots going to take over my brain? Are there nanobots in my brain right now? Like, I get weekly emails continually asking me the same question. I'm like, where on earth would they, like, where are people getting this from? And then I Googled. Don't Google. It's like, don't read the comments, right? Don't Google stuff. There are a whole bunch of websites out there. This is one of my favorites. This is a website that specializes, it's called dataasylum.com. And it explains how chemtrails contain nanobots that will take over your mind. And it comes with a video. Because people who don't understand nanotech are petrified by things that involve videos, right? Because then it's real. So it comes with this. And the scary music. Oh, nanobots taking over your brain. And it writes this whole article about how these nanobots in chemtrails, you breathe them in and they're living in you right now. And they attach to your neuron. And then they have these nanowires that protrude and they start to control your brain. Serious websites out there right now. The video says news. You believe it, right? People ask me all the time if there are nanobots in their brain because they see this.
That's true. Why don't I have superpowers yet?
And so I understand where people's fears are coming from. I really do, because the internet is full of things like this. And there's whole documents, and it's got links to things, and it talks about science, and you're like, oh, maybe it is. And it even gives you a way to experiment that they're in your brain. Read the site, it's great. It tells you to swirl your mouth with wine and then spit it out, and then you'll see little particles, and those are the nanobots that you're spitting out. No, seriously, it is one of the best websites I've seen. But for people who don't understand nanotech, to have a scientific-looking website that has a video, you can see why people think nanobots are in their brain. I'm going to reassure you right now, as a nanoscientist, that nanobots do not exist. I'm very sorry to break that news to you, but they don't currently exist. And this is why, because if you actually define the word nanobot, it is a hypothetical, that means they're not real, self-propelled machine that's going to cause all sorts of issues with science, that has some degree of autonomy and can reproduce. We don't make those things. It's not real yet. So to be self-propelled machine, as a nanobot has to be stated, it has to convert its energy into motion. Okay? It has to propel somehow. And the thing is, when you become very, very, very small and you go into a fluid, such as a body fluid, number one, water molecules are way bigger than you. So if you can move into them, they crash into you and destroy you. Number two, this thing called Reynolds number, which is about fluid flow, becomes very, very low, meaning that it's very difficult for you to move. And the only way you can move is if you have spontaneous energy propelling you. So there has to be spontaneous, non-symmetrical propelling, so bubbles are one example of how you could do this, to propel you in a direction. We really can't do this, and we can't control it, and it's really, really difficult. And we don't make appendages for nanobots yet. We can make nanomaterials, just about. I can do this in the lab. But I can't get different things to synthesize and attach to other things and then have function in a self-propelled way. What we can do, and this is where we are at, and this is the truth, is using external forces. So we can use ultrasound, we can use magnetics, external, to physically attract a nanoparticle that is static in a direction. So this is done in a petri dish, not inside a body. This is inside a cell. These are gold nanorods. And what we can do, and you can see we have no control over them, right? We're applying an external signal. It's either magnetic or it's acoustic. And we can get them to wiggle around. That is not ideal. Okay? That is not me putting nanobots in a controlled way in your body. We can also watch cat videos, apparently. Nanocat. That'll be the next story. So we don't make active nanobots. We don't do that. That is not a thing that we do. And it's going to be a long time before we do anything that actually fits the definition of what a nanobot is. What we do is we functionalize nanoparticles. So these are passive things. There's no propelling end. They're passive, and we can take a gold nanoparticle, such as they use in stained glass, and we can coat it with a coating that we call functionalization, and we can stick things on the end of it. So we can take a nanoparticle and stick certain things, and we can stick things like peptides on there that bond to certain cells, and this is what we can do. And this is actually really exciting. So this is reality. We can apply fluorospheres, for example, to nanoparticles and peptides that stick, for example, to cancer cells. And what that allows us to do right now is inject these nanoparticles. They float around your body randomly, and if they happen to come across their antibody match, such as a cancer cell, they stick and they bond. And because they have a fluorosphere on them, we can then image them so they glow. What that means is they're only attaching to cancer. Now we can visualize cancer cells. Very passive technology. We don't have any control of where these guys float around in your body, and we can visualize them. Still very basic. Now we're working on things such as using light to heat them up to kill the thing they're attached to, and there's a lot of animal studies showing that this is very, very promising. It doesn't help though if you have a BMI of more than 30, because light can't shine through fat. So lose some weight if you do. If you don't, we're still at the very primitive stage. This is not an active nanobot. This is a passive nano-functionalized material. And that is what we do have in science right now. So back to that brain thing. Obviously, being a superhero, I still wanted to take over people's brains. This is what my research actually involves. So I've been creating this lab on a chip. That square is about 1 millimeter by 1 millimeter, and underneath it you can see little shiny dots, and those are little tiny microelectrodes. what I've been able to do is take human neurons, which are on the other side, they're glowing because they're fluorescing, and force them to sit in places that they don't really want to sit. And they're sitting on top of each one of those electrodes. And what I can do is annoy the crap out of one of them and see whether it tells all the others. Because neurons communicate through an electrical signal. And because I have microelectrodes underneath them, I can tell if they're telling the other guys that something bad is going on. Hey, this lady is poking me with a stick. Or, in the case of Alzheimer's patients, I'm trying to understand where that connection is lost. Does the one that I'm poking just stop talking, or do the others stop listening? And so now I'm taking over people's brains for good, not evil. I love this story. Nanotechnology is the next asbestos. No, it's not. And there are quality papers like the Daily Mail that keep publishing articles like this. And we laugh, but it's a national British newspaper. And this is what the population is starting to learn. Nanofibers used to make sports equipment and nappies. What? Since when have nanofibers been put in nappies? I used to work for Pampers. I know, we don't do that. It can be just as dangerous as asbestos. There is no commercial nano product that is a fiber that we sell right now in any of my knowledge that is as dangerous as asbestos. And if you read the study that they refer to, the thing that acts like asbestos is asbestos. So they do this whole series of tests with these nanofibers, and then they make microfibers, and then they make macrofibers. And the thing that acts like asbestos is something the same shape and size of asbestos. That is not a nanofiber. This whole story is ridiculous. But what it does is create fear in people that nanotechnology is like asbestos. It is not like asbestos. And actually, I make nanofibers using electrospinning. We do it here in chemistry, and I have a place in Henderson where we can do it on the big scale. Big scale is to make more, not make bigger fibers. And what you can see here is a pollen, piece of pollen, and nanofiber mat underneath. So now I can filter your air filter system if you have allergies, to filter out pollen particles. You'll see products coming from me really soon, so I'm making this nano pillowcase, and it's made out of nanofibers, and it stops things like allergens getting through your pillow. So now you can sleep better. It's not scary, it's just small. And what it's able to do is filter out lots of things. So we're putting them into HRV systems, we're putting them into dust masks. We're actually protecting people by creating smaller holes. And the other thing we're doing is wound healing. So we can actually electrospin collagen, a very natural product, and put it over burns patients. And if any of you have ever cut, you know the web here? It's like the worst place to get a paper cut. And you can't do anything with it, because you try and put a plaster or a Band-Aid on there, and your body is not made for that. But the thing with wound healing is if you get nanosheets, you can actually just stick them on the top, and they just conform to the shape. And now you can create a protective barrier using nanofibers that are nothing like asbestos. And we actually make them from fish collagen. So it's a product that we throw away, and we just take the bits of the fish that we don't use, we spin them up, we take the collagen out, and then we electrospin them into a device that can help burns patients and people with wounds. The thing that I'm really looking forward to, and this doesn't exist yet, so this is one of my close things that are going to happen soon. So these are zinc nanowires that I build in the lab downstairs. And what we've been able to do is entwine them around fabrics in your clothes. And if you've ever heard of the piezoelectric effect, if you have one of those barbecue gas things, or you do that, you know, what are they called? Do they have a name?
Like wind-up radio sort of thing.
Yeah. So if you create motion through energy and you happen to move, I move a lot when I walk and talk, that fabric having these nanofibers against them creates electricity. And I have this dream of charging my phone in my pocket. And so we are now creating fibers that have these nanowires on, and we're working with fabric technicians to make them sturdy enough to wash. So now you can power things with your clothing. Because you're already creating that energy, why don't we do something with it? And so again, nothing like asbestos. And don't worry, because there are good people in good places who worry about this stuff. We have nanotechnology, nanotoxicity centers. We have them in Europe, we have them in the US. We don't really have them here, but we're a tiny country who don't make much nano stuff. And these guys have meetings, and they churn up data, and they run big experiments all the time to make sure the stuff that we're making that is nano-sized is safe. And so it's not like we just make nano products and like, ta-da, here you go, take your risk. We have people who are paid and governments who are paid to actually look at that risk. So people who are worried about stuff, there are good guys in white suits who are actually doing things like nanotoxicology studies. So, chapter 5. Sunscreen is killing the whales. No, it's not. Just so you know, the whales are perfectly fine. I like whales. Sunscreen is good for you. Okay, let's start at the beginning. So we can go to, and I can give you 100 web pages which explain that coconut oil is the same as sunscreen. And because sunscreen is so dangerous, because it has nanoparticles in it, you should just put coconut oil on. Don't. Please don't. It's an oil. So, coconut oil does have an SPF factor. It's 4. We live in New Zealand. That's not going to help you at all. If you're going to do an oil, use olive oil. It has a factor of 7. But please don't do this. So there are all these natural, and there's recipes online for how to make your own sunscreen with coconut oil. And it's one of the most dangerous things, and people are saying do it with your baby because you don't want artificial products on your baby. Please just put a natural coconut oil on your baby and it'll be fine. And this is why the system is broken. And this is why I talk about sunscreen all the time. Please don't do that. Please use sunscreen. Look, it's not that dangerous, okay? It comes in a bottle. It's not going to attack you. So what happened to sunscreen and why are people scared of it? Well, those of you who predate the 1980s may remember that sunscreen used to be white. And you used to be able to tell when people had it on. You could see a white sheen on their face. This is old sunscreen versus new sunscreen. I have sunscreen covering my whole face. Half of my face you can see the sunscreen on, half of it you can't. It's the same material. It's the same product. The difference is the size of the nanoparticles. So we either use zinc oxide or titanium dioxide particles in sunscreen as a UV resist. And the size of the particle depends on whether you can see it. So when you pluck the hair from your head, you could see it. When you make the zinc oxide big enough, you can see it. When you make it smaller, you can't. It doesn't mean it's not there. It just means that we've reduced the size to be the nanoscale so that your face doesn't look white anymore. And it also feels less oily. So we put nanoparticles in sunscreen, mostly for aesthetics and to make it feel less greasy. But the function is exactly the same. And I know I'd much rather walk around with it being transparent than having this thick, crusty, white sunscreen on my face. But because it has the word nano in it, everybody had a little panic attack. And all these websites came out about how you shouldn't use sunscreen because it has nanoparticles. And I'm like, okay, but it's protecting you from the sun, and let's look at skin melanoma, and let's look at skin cancer, and let's think about the risk that you're going to take if you don't use this. I bought a sunscreen the other day that it said, no nano, and a big cross over it, and it said, microdized. I'm like, that's not even a word. That is a made-up word. I don't know what that even means. I don't know how you've proved it. So I have no issue, based on the scientific literature, that sunscreen is going to kill you. Wendell Neeson. We are having a big scrap right now. How many of you have heard of Wendell Neeson? Yeah. Right? Unfortunately, prominent New Zealand celebrity. Writes for the New Zealand Herald, has a column, is on all the big national radio stations talking about natural products and natural cleaning and natural this, and has a huge following. And she posted this blog recently. It said, how sunscreen is bad for the whales. Her advice is, try and spend most of your time in the shade. How's that advice? If you're at the beach, I'm a surfer, I don't want to like surf with an umbrella up. Like, that's just not practical. It's not going to. Right. And so she wrote this lovely blog article about how you shouldn't put sunscreen on and you should just sit in the shade because then you're saving the whales. And I was just like, that is probably the most ridiculous thing I've ever heard. So I contacted her. I'm like, dear Wendell, I was all lovely. I was like, not really. And she's like, yes. And I'm like, no. And she's like, totally. I'm like, have you read the original article? She's like, no, but I read a blog post from somebody that I know that said it was true. Right. So as a scientist who specializes in nanotech, let me break this original article paper down to you. The study was done in a little pool of the Mediterranean Sea that has a massive tourist population, lots of people swimming in water that has no flow, that is very high temperature water, and they noticed that some of the sunscreen was in the water. And it contained titanium dioxide nanoparticles from the sunscreen, no big deal. They then did a different experiment that says if you put sunscreen in water and put light on it, it creates hydrogen peroxide. Okay, that's true too. They then decided that because plankton in the ocean is destroyed by hydrogen peroxide, therefore, if people swim in the sea, the plankton would die. Hold on, there's no correlation to those two separate experiments and what they just said. Then they said, well, whales eat plankton. So therefore, the whales are all going to die. So there's a whole sequence of scientific events that happen that are not correlated to each other for this conclusion to have been made. I am not worried about the whales. I'm not worried about New Zealand's oceans having sunscreen in it and that killing our plankton. We have great flow through the system, and actually the nanoparticles break down with the light very, very easily once they're immersed to the salt water. This is fabricated, and Wendell and I are still fighting because she won't pull down this blog post. And I'm like, I think this can be dangerous because you're telling people to apply less sunscreen to protect the whales. And sunscreen has nothing to do with whales. And people like whales, right? It's that whole emotional connection of save the whales. No, don't. Put sunscreen on. Save yourself. The whales are totally fine. So what do we know about sunscreen? Over 400 peer-reviewed articles on the safety of nanoparticles in sunscreen. I have read them all because people keep asking me about, is sunscreen going to kill me? I can tell you that there is no evidence that nanoparticles in sunscreen penetrate your skin, whether it's healthy or if you have diseased skin. So then they created an artificial experiment where they cut your skin to make the nanoparticles go inside. Right? This is what they do in science. Don't look at me like that. It's not me. So then the nanoparticles went inside, and you have these amazing things. They're called lysosomes. They're like the feeders in your body. They eat everything that's not supposed to be there, and they gobble them up within 24 hours. And then you excrete them like any other waste product. So even if they do get through your skin, don't worry. You've got these big things called lysosomes that attack them and then kill them and destroy them. What's interesting is if you don't use sunscreen with zinc or titanium dioxide, you're exposed to 20% more UVA radiation. And if you use these zinc oxide, titanium dioxide nanoparticle free, your product sunscreen has actually more things that cause cancer in there than less. So they're highly hazardous ingredients that they're putting in there instead to replace these nanoparticles that are much, much more linked to birth defects and other carcinogenic materials. So your natural products may actually be more dangerous than your standard, highly tested sunscreen. So my personal opinion, based on reading lots and lots of things and articles and being outside in the sun a lot, is I'm totally fine to use these nanoparticles on my skin. And if anything changes, I will let you all know. But don't feel bad about the whales, because they're just fine. So obviously people always ask me about nanotech, and it's really hard to talk about a subject that I do so much in and that is so diverse. But they say, do you have any other superpowers? Of course I do. This is why I'm a nanotechnologist. So what have I done recently? Number one, I've been banned from the zoo. Because somebody said to me that geckos don't stick to Teflon. And I'm an experimentalist, and I don't own a gecko. So my girlfriend said, oh, I know somebody who works at the zoo. You could probably, take a look at the geckos. Because I was like, hey, they have nano hairs on their feet, and I'd really like to look at them. And she was like, okay. And secretly, I wanted to experiment on them. But I didn't say that because I knew that. So I went to the zoo, and they're like, hey, here are the geckos. I'm like, cool. And they're pretty big ones. She's like, you can pick one up. I'm like, okay, thanks. So I pick up the gecko. Oh, look, nano hairs on the feet. Can't see them, but I'm sure they're there. The girl turns around, and I pull out of my handbag a massive frying pan. Because it's the only thing I know that you could buy instantly that had Teflon on it, right? So I seriously sneak out, and you said... So I hadn't thought this through, because I had my iPhone, which I was going to video it on, but I've got phone, frying pan, gecko. So I was like, which one do I give up? So I'm trying to put the phone in my mouth on record so I can record like this. And I got this gecko, and I got the frying pan, and I'm like... and the girl comes back in, right? And I'm holding a frying pan up to her gecko. And it looks terrible. And as much as I try to explain it was for science, it looked like I was about to bash her gecko. But anyway, geckos don't stick to Teflon. And the reason why they're really good at being heavy lizards but climbing things is because they have these nanohairs on their feet. And so I do this thing called biomimetics where I copy nature because I figured I'm not going to think of a new idea myself, so I might as well just copy something that's already been done. And so I've been using 3D printing to make nanohairs, just like gecko nanohairs, to make sticky tape that sticks forever. We call it dry adhesion. And this is a really fun project that I'm doing right now. My whole goal is obviously to have a gecko suit so I can just climb walls, but I'm telling science that there are real reasons why we should use this. And actually we're designing it for robots. So medical robots are used to help patients and they pick things up all the time. And our big problem is how do you get an artificial robot hand to pick up something gentle without crushing it? And so what we can do is we can line the hands of these robots with these hairs and they just stick and they can lift it up with much less force and put it back down. That's one of the things I'm doing. Number 2, invisibility. I'm all obsessed with invisibility. So those of you on the front row should be able to see that this is a bag of water. Yes?
I confirm.
You confirm?
Not tequila or...
Not well. It's a bit early, really. And so the thing about invisibility, it's all about changing the way that light behaves. So if I put my hand into this bag of water, you should see that actually there's a solid object inside. And what you do is you refractive index match. So what happens is at this state, so light bounces through things at different speeds. So you can see it now, you can't see it now because it's invisible. It's not really invisible. You've matched the refractive index. I will let you play with this. I'll put it in a bucket and I'll pass it around. So refractive index matching is one way. The other thing we can do is metamaterials. So metamaterials are just materials that are made that can't exist naturally, but really, really good in nanotech of forcing things to behave in a different way. And so we can force atoms into spaces that they don't normally go into. Please don't squash it until it's gone around the room because it will shatter eventually if you put enough force on it. And so making things invisible, what we can do is we can make things invisible, but only very, very small things. So metamaterials do exist. They do cloak materials. They cause light to bounce around so you can't see them, but they require a lot of power. Where we are right now is we are not able to do it on anything big or structural. We're only able to do it at a very, very small scale. So when you hear about invisibility cloaks, they don't yet exist. And this is what we will be using to do it, and we are nowhere near making it cloak big things. We can cloak like 3 atoms, and that's not very cool. And finally, superconductors. And I'm a little bit obsessed with superconductors, and I did bring a little experiment, and I'll do it at the front if you want to see it later, because the presenter camera isn't working. Superconductors are freaking amazing, and they're amazing because they don't take the energy out of electrons when they pass through. So if you're an electron, such as electricity, and you want to pass through a material, you bounce off all the atoms and you lose energy. You know this because you see birds sitting on the wires outside your house. And you're like, oh, they must be chatting. No, they're not chatting, they're warming their feet. Because it's toasty warm on an electrical wire. It's toasty warm because that electricity that is passing through is losing energy through heat, and the birds are all toasting their feet. That's not great for efficiency. So how do you get electricity from one place to another, or from one country to another, without losing that energy? I mean, the birds are going to be a bit annoyed, right? But other than that, we will actually be able to have more efficiency in our power transfer. We're doing this through superconductors. So superconductors actually allow electricity to pass through with no loss of energy. And that's awesome, apart from they can only do it at minus 110 degrees. And I don't know about you, but I like the temperature outside right now. So we are currently making high temperature superconductors, and that's the minus 110. We are nowhere near right now making them happen at room temperature. The goal, and people talk about nanotech, but like, yeah, we're going to do this. Look, I'm going to be honest with you, we're not there yet. But we're trying to understand how superconductors work so that we can maybe get there. But the reason why I love superconductors is for this, and I will do this experiment with you guys later if you want, and that's the art of levitation. And so you can see this later. If you chill it down enough, you can make magnets levitate. And that's just fun. And I'm in the process of trying to make a superconductor that's big enough. I either have to dye it a little bit more or make a bigger superconductor that will make me levitate. So that's happening for a big show that we're doing. Anyway, that's coming up in March. So that's superconductors, and that's a whole story about fictional nanotechnology with a little bit of reality, and that's what I do as Nanogirl. So thank you.